Heinemann Higher, Differentiation, Chapter 6, Mixed Questions at the end, Exercise 6S. Number 4, find the equation of the tangent to a curve. This curve at this point. Now, soon you'll get to appreciate that a positive x cubed curve will look like this. So at this point here, which I happen to know because I looked at that earlier, is beyond that turning point, it's going to be somewhere here. The tangent at the point x equals 2 might be here, so it looks as if it's going to be very steep and cut quite far down. Since that's a line, there's two things I need to know about that line. I need to know, I'll just put in the form of y equals mx plus c just now, hopefully. I need to know a point on it, I need to know the point xy on it, and I need to know its gradient. Right, well first of all, that's an equation that says y equals, so that's a coordinate equation. Put in the x coordinate, you can work out the y coordinate. If I want the gradient, I differentiate it, dy by dx. Simple enough, multiply by the power, take 1 off the power, linear term, so just minus 1. So that will be the gradient equation. So it's just a case of put x equals 2 into this, and I'll get its y coordinate, because that's what that says, y. Put x into this, and I'll get this thing, dy by dx, which is the gradient, difference in y over difference in x. So, do those. X equals 2 means y will be 3 times 2 cubed minus 2 plus 6, for which you could just use your calculator, I suppose. So you've got 2 cubed is 8, 3 8s are 24, minus 2 plus 6, 30 take away 2, so that's going to be 28, which means it's going through the point 2, 28, that's the first bit. So this tangent is definitely passing through that point. Gradient, well, I'll put this here. If x equals 2, that means the gradient will be dy by dx, which will be 9 times, put 2 into it, 9 times 2 squared minus 1, 2 squared is 4, 9 4s are 36, take away 1, 35, so the gradient's 35. Then, unfortunately, that wasn't the point on the y-axis. If that had been the point 0 something, I could just have fed in straight away y equals mx plus c. Gradient 35, and c would have been wherever the y coordinate was, but it wasn't. So I'll have to use that alternative form. Y minus b is mx minus a for the tangent. I should have said. Line up your dots. And I don't need to specify them again here because that's all there is. I've only got that point and that gradient. So y minus its y coordinate, 28, is the gradient, 35. X minus its x coordinate, which is 2. All nice and integral. So I'm just going to write it as y equals mx plus c. That's a good form for it because you know what it looks like and it's perfect for substitutions. So I've got 35x minus 70 but plus 28. So finally, y equals 35x minus, take off 30, add on 2, minus 42. There it is. The equation of the tangent to that curve at that point where x equals 2. Question 4.